This question comes from Daniel, who asks, if the Chicxulub asteroid had missed 66 million years ago, what would the world look like today? To understand the answer, you first have to appreciate what the world looked like just before the impact. The asteroid was roughly 10 to 15 kilometers wide, about the length of a small city, and it hit what is now Mexico's Yucatan Peninsula at around 34,000 miles per hour, excavating a crater 180 kilometers across. It vaporized sulfur-rich rock, threw debris into the upper atmosphere, blocked sunlight for roughly 2 years, and effectively switched off photosynthesis globally. Any land animal weighing more than about 25 kilograms, the weight of a medium-sized dog, was dead within a few years. The non-avian dinosaurs, along with the pterosaurs and the large marine reptiles, were gone. The critical question is whether the dinosaurs were already on their way out. This is genuinely debated. A 2021 study in Nature Communications analyzing 6 major dinosaur families found that dinosaur diversity had been slowly declining for roughly 10 million years before the impact, driven by cooling climates and the loss of large herbivores that destabilized ecosystems. But a separate 2022 study in Science Advances, which reconstructed North American food chains right up to the boundary, found dinosaurs with stable, thriving ecosystems until the very end, with no sign of being displaced. The consensus view, as Steve Broussard of the University of Edinburgh put it, is that dinosaurs were going strong right up to the moment the asteroid suddenly killed them off. This matters enormously for the question, because it means that without the asteroid, nothing else was likely to unseat them. Mammals had already been living alongside dinosaurs for roughly 165 million years, as long as the entire span from the dinosaur extinction to today, without ever breaking out of the ecological margins. Throughout the Cretaceous period, they remained mostly the size of mice to shrews, almost certainly nocturnal, and confined to ecological niches that dinosaurs weren't using, foraging for insects in the dark, burrowing, scrambling through undergrowth. A few exceptions existed, some larger aquatic forms, occasional herbivores, but the general picture is of a group spending 165 million years crammed into the corner of the world while something larger dominated the center. There is no sign in the fossil record that this was about to change. So in a world where the asteroid misses, the most likely outcome is more of the same. The dinosaurs continue, the large mammals don't arise, and the world 66 million years later is still a dinosaur world, bigger herbivores, and the predators that hunt them. Birds is one successful lineage of small dinosaurs, and the small nocturnal mammals still quietly occupying their peripheral roles. The deeper question, and the one that makes paleontologists genuinely uncomfortable, is whether intelligence was inevitable anyway. In the 1980s, paleontologist Dale Russell proposed a thought experiment in which a carnivorous dinosaur called Troodon, which already had one of the largest brain-to-body ratios among non-avian dinosaurs, continued to evolve. His projected Dinosauroid walked upright and had enlarged hands and a larger skull. It was an exercise in imagination, not a prediction. Nicholas Longrich of the University of Bath, writing more recently about this question, noted that there is almost nothing in 100 million years of dinosaur history to suggest they were trending toward anything like human-level cognition. Their brains were growing but slowly, and in directions suited to their existing ecological roles. Large brains, by contrast, evolved repeatedly in mammals after the extinction in orcas, sperm whales, elephants, great apes, suggesting something about the mammalian body plan, was unusually prone to producing intelligence once it was given space to diversify. Whether dinosaurs would ever have gone the same route is unknown, but there is no particular reason to assume they would have. What we can say with more confidence is that we would not exist. The primate lineage that eventually produced humans required the extinction of the dinosaurs to get started at all. The first mammals to behave like modern daytime animals appeared approximately 200,000 years after the extinction event, according to research published by Mao and colleagues in 2017, meaning that for the entire reign of the dinosaurs, our ancestors were operating only in the dark. Within 300,000 years of the impact, mammal body mass had already tripled. Within 700,000 years, the first large mammals had appeared. The entire trajectory of mammalian evolution that led to primates, then apes, then hominids, was unlocked by that single event. Remove the asteroid, and you remove the unlock. The exact thing you're made of 66 million years of mammalian evolution. culminating in a large-brained bipedal daytime primate depended on a rock from space hitting a specific peninsula at a specific angle on a specific day. Hit 30 seconds earlier or later, some models suggest, and the asteroid lands in ocean rather than sulfur-rich shallow rock, producing a far less devastating impact. The Deccan Traps volcanic eruptions in India were already underway and might eventually have stressed the dinosaurs on their own, or might not have. The details are everything, and the details happen to add up to us.